All right, we're about to dive into a question that sounds so simple, but it's actually one of the biggest puzzles in all of architecture. It's a decision you probably walk past, a dozen times a day without even giving it a second thought. No, I'm serious. Think about it for a second. In some massive building with thousands of people moving around, where do you actually put the elevator? As we're about to find out, the answer isn't just about what's convenient. It's about the very lifeblood of the entire structure. The best way to think about an elevator system is to imagine it as the building's beating heart. It's literally pumping people and goods through the structure, right? It's keeping everything moving, functional, and alive. And if you put that heart in the wrong spot, well, the whole system just collapses. And that's exactly why deciding where the elevator goes is one of the very first, most critical calls an architect has to make. It's not some detail you just sprinkle in later. Getting this wrong can cause massive, costly redesigns, total structural nightmares, and a building that just plain doesn't work for the people inside it. So how do they even start? Well, before a single line gets drawn on a blueprint, the design team has to basically become a doctor. They need to diagnose the building's needs by analyzing the flow, the literal circulation of people that will move through its veins every single day. And to make that diagnosis, they ask some really critical questions. What's this building for? An office with a huge 9 a.m. rush hour is a completely different beast than a hospital, which obviously needs big cars for stretchers. How tall is it? How many people are going to be using it? That's going to determine the speed and capacity you need. Even something as simple as where the front doors are is huge, because the elevators have to be easy to get to from every single entrance. And that's all before you even get to special needs, like a dedicated car just for firefighters. It really all boils down to this. A skyscraper at rush hour and a small apartment block are two different worlds. The office building might need a super smart destination control system to handle the crowds, while the apartment just needs a simple, tough, reliable car. The building's unique personality, its DNA, that dictates every single decision that comes next. Okay, so once the team figures out the building's needs, the what, they have to tackle the where. And this is the art of strategic placement. It's this delicate, constant balancing act between the perfect solution and what's actually possible. Now, the process seems pretty straightforward on paper, right? Analyze the traffic, pick the right kind of elevator, and find that perfect central spot. But here's the catch. You immediately have to check for clashes with the building's skeleton and all its other systems. And this creates this constant cycle of coordinating and revising over and over again. And this gets us to the real battle that architects are always fighting. In a perfect world, the elevator is right in the middle, super easy to find, and right next to the stairs for safety. But in reality, an elevator shaft is just a giant vertical hole. Put it in the wrong spot, and you could seriously weaken the building's structure, or crash into plumbing, or stick a noisy, vibrating machine right next to someone's bedroom. The first rule, the absolute #1 golden rule, is this. You do not compromise the building's skeleton. The elevator shaft can't just slice through main support columns, beams, or anything critical. This means there has to be this incredibly tight coordination with a structural engineer from the moment the project begins. And then you've got fire safety, which is completely non-negotiable. Elevators have to be located near stairwells. It has to be an intuitive, clear escape route in an emergency. There are also super strict codes that dictate things like firefighter access and demand that the entire shaft be wrapped in fire-resistant walls. And, of course, we have to think about the human side of things. An elevator is a machine, it's got motors, it's got cables, and it makes noise and vibrations. Now, in a hotel or an apartment building, if you stick that shaft right next to a living space, you can make it totally unlivable. So architects have to plan for sound, often using special insulating materials just to buffer all that noise. So how on earth do you solve this game of three-dimensional chess with so many competing rules? Well, the answer is you don't do it alone. Placing an elevator is like a symphony conducted by a whole team of specialists, and they all have to be playing in perfect harmony. The crucial thing to get is that this is a team sport. You've got the architect, who has the big picture vision. The structural engineer is there to make sure the building literally stands up. The MEP engineer, that's for mechanical, electrical, and plumbing, they make sure the elevator doesn't run into a giant pipe or critical wiring. Then you have the elevator supplier, who brings all the technical know-how. And finally, the client, who has the final say. No one person can possibly do this by themselves. In the past, this kind of coordination was done with giant piles of paper blueprints, and it was an absolute nightmare. But today, they have an incredible tool. It's called BIM, or building information modeling. Software like Autodesk Revit creates this amazing, detailed 3D digital model of the entire building. It lets the whole team see exactly where a pipe might hit a beam or where the elevator shaft is a little too close to an office, letting them solve these problems on a screen instead of on a chaotic construction site. And believe me, this process is anything but a straight line. It is a constant loop. The architect suggests a location. The engineers take a look and find like 3 different problems. So the architect revises the design and the whole team reviews it all over again. They just repeat the cycle. Design, review, revise, repeat, slowly chipping away and refining the plan until every single constraint is met and every expert is happy. So after all of that analysis, all that negotiation, and all that digital modeling, the elevator finally finds its home. And for most of us, the end result is, well, it's invisible. We just walk in, press a button, and arrive at our floor, never once thinking about the incredibly complex logic that put it right there for us. And that right there is the key takeaway. Why does all of this matter so much? Because a well-placed elevator system isn't just an add-on, it's foundational to what makes a good building. Thinking about it from day one saves a ton of time, a ton of money, and prevents huge headaches down the road. It literally defines the flow, the efficiency, and the entire experience of being in that space. So the next time you're in a lobby waiting for an elevator, just take a second, look around. Notice where it is in relation to the main entrance, to the stairs, to the shape of the room. You might just start to see that invisible blueprint, that hidden logic that was so carefully crafted long before the first brick was ever laid.